I'm going to go ahead and get started. I'd like to introduce our next speaker, Yuta Saito. His background is in material science and engineering with a focus on fatigue and fracture mechanisms. And he did that while learning that before joining Shinto Kogyo. After joining Shinto, he belonged to the development group that has been involved with research on fatigue, metallography and X-ray diffraction analysis. And then more recently, he's been involved and took over the responsibility for laser peening and has been applying it to various materials and verifying the effectiveness for use for a Shinto Kogyo. And with that, I'd like to introduce Yuta and allow him to start his presentations. Welcome, Yuta.
Okay, thank you for my introduction. The title of my presentation is the effect of laser peening and the aromatic treatment on fatigue properties of A7075 alloys. The researchers are Yuta Saito and Dr. Kobayashi of Shinto Kogyo Ltd. and Dr. Yuki Nakamura of National Instructor of Technology Kyoto College. Our presentation will be given by Yuta Saito. Yeah, let's start. The subject looks like this. First, let's talk about introduction. First, I would like to explain about our company. Our company name is Shinto Kogyo Ltd. The head office is located in Nagoya, Japan. The company was founded on October 2, 1934. The number of employees are approximately 4,000, including consolidated. The company's main business are surface treatment, foundry, environments, and etc. The sales ratio is shown here. The company boasts the largest share of the surface treatment market in Japan. Next, I will explain the history of technological development. We are a company that started with casting equipment. So we developed a shot blasting machine to remove sand from the casting made from the casting equipment. We then proceed to develop shot peening machines for surface modification treatment and the barrel finishing machines. We also started laser peening to accommodate it of the variety of the applications. And I would like to explain our surface treatment business in more detail. Our business includes the sales of the shot blasting machines, barrel and brush machines as shown here, and contract processing. Among surface treatment, we specialize in deburring, removing, roughening, polishing, chipping, and peening, which are applied to the products shown here. Next, I would like to introduce CITIA. CITIA are non-contact, non-destructive device for the evaluating the condition of products after peening. CITIA are intended to visualize the surface processing of the products at the manufacturing factory. The first is the ECNI2. ECNI2 are ethically current non-destruction inspection system that use eddy currents to evaluate the state of the metal structure inside the material. ECNI2 can determine the processing state of the shot peening in just 1 second by using changes in resistance value accommodating in the change the metal structure. The other is a portable X-ray laser stress measurement system that measures laser stress on the material surface. The PSMX2 is an inline type for the field use, and the Micro X360S is an offline type for the scientific purpose. And this figure shows the certification measurement result stress, CMRS. CMRS is used to confirm the measurements taken by the X-ray result stress measurement system are correct. Until now, you have been using the 0 megapascal iron powder to confirm the measurement values. However, the result stress value of the target part is not 0 megapascal, but the measurement equipment is calibrated at the 0 megapascal. The material is evaluated is bulk, but it is checked with metal powder. Don't you feel uncomfortable? The CMRS was created to meet the needs to those who want to confirm to the target stress value with the same material. Okay, this presentation is main contents. So aluminum alloys are used in automobiles and airplanes due to their high specific strength and the high corrosion resistance. The figure 1 shows the rate of used materials for the automobiles. The rate of steel use is decreasing year by year. On the other hand, the ratio of aluminum alloys, magnesium alloys, the carbon fiber reinforced plastics is increasing in order to reduce weight. Figure 2 shows the percentage of the materials used for the airplane. The use of the aluminum alloys is the second most, accounting for the 20%. However, it is necessary to improve fatigue strength and wear resistance in order to achieve feather weight reduction. So, peening is one of the methods in improve the fatigue strength. Two major methods of peening are shown here. Shot peening is a use of metallic or non-metallic special media, which is called shot media. The shot media is accelerated by the various methods. So accelerated media impact on the processed surface, and then plastic deformation is generated at the surface. Visual stress is generated to the constrain the plastic deformation layer by surrounded base metal. Furthermore, the plastic deformation generates work hardening. On the other hand, laser peening is a technology to peen the surface of the workpiece by irradiating the pulse laser in the water, or the water flows over the workpiece. I'm sure you all know that I'm talking about. So sorry, I'll skip the detailed description. Laser peening can introduce deeper compressive result stress, higher repeatability, and more localized processing compared to the shot peening. However, when processed a large area, laser peening takes more time compared to shot peening. The next method to improve wear resistance is Aromatic treatments. The characteristics of the Aromatic treatment include improved wear resistance, improved corrosion resistance, and decreased fatigue strength. The structure of an Aromatic layer is shown in the fatigue 5. The program here is a decrease in fatigue strength. This figure 6 shows the Aromatic formation process. Aromatic not only forms on the surface of the aluminum alloy, but also alloys into the inside of the aluminum alloy. In the case of a shot peened, the heating and erosion during the treatment cancel the effect of the peening, so effective compressive result stress layer is disappeared. Therefore, we thought that the program could be solved by laser peening. In Korea, it has been issued that the compressive result stress introduced by the laser peening is retained even even after heating to 500 degrees. From this issue, we thought residual stress can be expected to be retained even after aromatic treatment when applied to aluminum alloys. Also, it has been issued that the compressed residual stress was introduced to the depth of about 0.6 millimeters in aluminum alloy A7075. During aromatic treatment, effective compressive residual stress layer remains even if the pinned layer is eroded. So we have investigated the retention of the compressive residual stress and the effect on fatigue properties after laser pinning and aromatic treatment. So A7075 was used as a specimen material. Table 2 and Table 3 shows the chemical component and the mechanical properties. Figure 8 shows the shape of specimen. The stress concentration coefficient of the test specimen was made to be 1.08. This page shows the manufacturing process of the specimen. The specimen that has been mechanical process and mirror polished is called UP. After that, the laser pinned specimens are called LP. On the other hand, the aromatic treatment specimens are called AT. Both laser pinned and aromatic treatment specimens are called LPAT. Next, I will explain the simple specifications of the laser transmitter used in this project. The laser type is ND-YAG laser. The laser is visible light of the 532 nanometer, the second harmonic. The pulse width is 0.2 nanosec, which is a nanosecond short pulse. The opaque layer is not put on, but the laser pinning is done in the water as shown in this picture. In this experiment, the spot dynamometer is set to be 0.6 millimeter, and the pulse energy was set to be 148 millijoule, resulting in the pulse density is 2000 pulse per square millimeters. This page is shown the method of fatigue test and the measurement residual stress. Vertical bending test was used to evaluate fatigue. The cycle speed was done at 3,150 RPM. The test was performed at room temperature. The fatigue limit was set at 1 gigacycles. The residual stress values were evaluated using an X-ray residual stress measurement system. A condition is shown in table 6. This page shows the result of hardness measurement and the residual stress measurement. In both figures, black circle mark is UP, red triangle mark is LP, blue square mark is AT, and the orange diamond shape mark is LPAT. A right figure is shown relationship Victor's hardness and the depth from surface. The surface hardness of LPAT and LPAT increased compared to UP. The LP condition shows that most improvement in hardness, rising to 238 HV. A right figure is shown relationship residual stress and the depth from surface. The residual stress measurement was not possible for the aromatic layer, so AT and LPAT were measurement from the deeper than the eroded layer. Compressive residual stress is occurred up to about 300 millimeter by the laser pinning. Compressive residual stress was not released by the aromatic treatment in LPAT condition. The figure is shown the relationship stress amplitude and the number of cycles. The figure limit values of stress amplitude were same for UP, LP, and AT. In the area of stress amplitude exceeding 400 megapascal, the fatigue life of LP, AP, and LP-AT is lower than that of UP. However, in the area of stress amplitude less than 400 megapascal, the fatigue life of LP and LP-AT is increased compared to that of UP. This figure is shown the fracture surface observation. The upper side of the fatigue shows each condition and the stress amplitude value. In addition, red circle in figure indicated crack initiation points. In all conditions, the fracture initiation point was from the surface. However, in the LP, AT, and LP-AT conditions, several fractures several surface crack initiation points were found. So, according to the result of fatigue test, why is the fatigue life of AT and LP lower than that of UP in the region where the stress amplitude exceeding 400 megapascal?
Yuta, I'm just going to let you know you got about 3 minutes left.
Oh, sorry, I'm hurry up.
Okay.
As a surface roughness increase, notch sensitivity increase. As a result, check initiation and the propagation and the accelerated. The surface roughness of UP is low because of the mirror polishing process. The surface roughness increases due to the formation of the infinite pores in the alumite layer. And laser peening increases the surface roughness compared to UP due to laser ablation of the surface. So next we discuss why the fatigue life of the AT and LP increased compared to that of UP in the region where the stress amplitude was lower than 400 megapascal. This figure shows the model diagram of the crack initiation under each condition. UP does not prevent the crack propagation because there were no factors to inhibit its progress. On the other hand, LP and LP-AT prevent the crack propagation because of the compressive pressure stress affected. So, conclusion. In this investigate the effect of laser peening and aromatic treatment on the fatigue strength of the A7075 were investigated. The result is shown here. Therefore, aromatic treatment after the laser peening on A7075 did not release the effect of laser peening. Thank you for watching our presentation. If you are interested, please contact me. That's all. Thank you.
Yuta, thank you for your presentation. We greatly appreciate you sharing the information and the progress that you're making. I guess just a quick question, and then we'll have to move on to the next presentation. But at this point, what has Shinto Kogyo done in terms of actually trying to apply it? You've done a lot of research, but is laser peening one of those tools that's going to become an important product line for Shinto Kogyo?
Sorry,
should I
please.
Ask question again? What is Shinto Kogyo doing in terms of implementing this as a manufacturing process?
Shinto Kogyo was started the testing because
Go ahead.
Sorry. Shinto Koryo was started casting technological development. So the customer hopes more program for example, the scale and the
Okay, I think you've answered my questions.